You guys will be so sick of me by the time the day is over. I am back again to intro our next session, which is insanely, extremely exciting and has a lot of heat right now in the space because it matters. As I mentioned in the kind of kickoff presentation this morning, one of the biggest challenges in the entire AI space is a shortage of chips. There are not enough chips to go around. And what that means is not only is AI progress kind of held in check, but also it means only the very biggest players in the field can go to the table. It takes billions and billions of dollars to build AI. So an exciting new space is wondering, hey, can we use decentralized compute? Can your laptop and your laptop and your laptop be cobbled together to create compute that can help train AI that can kind of make it more inclusive? So small, scrappy startups can come to the party and make AI creation more competitive. That's the goal. Of course, it's not easy. So we have an incredible panel of smart folks in the DePIN space to really get into it, to discuss what are the opportunities, what's the potential, but also what are the very real challenges. So please welcome Dr. Ben Fielding, Andrei Radonik, Jensen, and John Stokes.
Thank you to the panelists, and thanks for Jeff for the intro. I'm going to go ahead and go through each of you in line and ask you to introduce your project super briefly and talk about what you're doing in DePIN. Jensen.
Hello, everyone. My name is Jean. I'm one of the co-founders of Outex network. What do? We are probably the earliest and the largest modular platform to enable all type of DePIN projects, DePIN networks to build and launch their network on top of the blockchain. So I just want to ask a question. How many of you know what DePIN stands for? Wow, impressive. It's over 50%. Yeah, so DePIN stands for Decentralized Physical Infrastructure. All type of physical networks like, wireless network, like, energy network, computing network, GPU network, all type of device network will be like, foster our current kind of, the word utility you are using in the physical world. Yeah.
Andre.
Hey everyone, I'm Andre. I'm one of the co-founders of Grass. I guess put simply, we're a network of now over 2 million devices that are running software that scrapes every corner of the public web. I guess obviously by getting a lot of people to share their unused internet bandwidth and adding that all up, you can actually scrape a lot of data, which is then fed into AI models and all kinds of other applications. Pretty simple, but I guess it works.
Hang on a second. Just a note to the audio guys. If we could get more monitor up here, I'm having a hard time hearing the other speakers. Thank you. Go ahead, Ben.
Hey everyone, I'm Ben. I'm the co-founder of Jensen. We're a machine learning compute protocol. So we connect up machine learning capable compute hardware like GPUs as a big example, but also TPUs, CPUs, any device that's capable of doing machine learning training work and allow those devices to be used by anyone who wants to train a machine learning model. So you can think about us as a huge global network of theoretically all of the machine learning capable compute hardware in the world that's accessible to anyone at a fair market price. We think of ourselves as very, very low level, so a little bit like TCP/IP for the internet, but purely for AI, machine learning, compute power across GPUs and then ultimately TPUs, CPUs, any device.
So I'll introduce myself. So I'm John Stokes, and I'm co-founder and CTO at Symbolic AI, and we're a Gen AI company for enterprise content production. And we're kind of Web 2 a little bit. And so I'm going to ask the panelists here to DePIN pill me, if that's possible. As you can see, I'm old by the standards of crypto. I am from back in the day where decentralized is a synonym for peer-to-peer, and peer-to-peer means it doesn't actually work. I remember Napster, I remember Quake, all the old school things that were, peer was constantly resetting our connections, whoever peer is. So talk to me about how I, as a founder who is calling, now I'm calling a set of centralized APIs right now for inference, and those don't work either because of the GPU shortage. So talk to me, Ben, a little bit about your story How does decentralized GPU networks like what you're building, how does that compare right now in terms of the metrics that I care about? First off, are you doing inference or is it just training and fine tuning? And how does that compare in terms of uptime and availability and latency?
Yeah, it's a really good question, and it's one of the reasons to your kind of final point of your question. We focus on training and fine-tuning specifically because inference is, in our view, a latency game. Like, people care about the speed of answer and the fact that they get an answer. So redundancy there is very, very important, and speed of response is incredibly important. For now, centralized services are probably the best bet. For people in your position where you need that answer, you rely very, very heavily on that service. I think in the future, we can build robustness into these systems. As you bring down the costs of compute and the cost of the other aspects, the cost of data and things, you can build in the redundancy that we see in distributed systems, and you can plug what is essentially one of the downsides of decentralization with those technologies in order to get some of the upsides. On the upside side, we see the solution to a large trust problem which sits in front of scale. So decentralization allows us to reach absolutely maximal scale by replacing some of the centralized world trust mechanisms that we have right now, i.e. if I want to get a bunch of GPUs from AWS, I trust AWS will give me those GPUs. I don't need to do any work to verify that when I run operations on those GPUs that AWS has actually done those operations, because I know through the kind of human world I've got ways of regaining value if they haven't done it, and broadly their reputation means that they probably won't do anything. If I want to access many, many, many more GPUs, I still need to establish that trust with all of those devices. And at some point, that hits a scaling limit where the administrative costs of establishing human world trust outweigh the benefits of expanding further. Decentralization removes those costs by replacing those trust mechanisms with technology. So we, instead of using those human world kind of legal contracts and things to establish trust, we can use code, essentially. That's really, really good. It lets us build massive, massive, unlimited scale networks. But like you said, it doesn't quite work for those situations where we want kind of immediate sort of redundancy, immediate responses, very, very fast responses. So one of the reasons why we focus on training specifically. I think eventually inference will be a good use case for decentralized networks. Once you have enormous coverage with a decentralized network, it works. But growing that coverage, there's going to be growing pains. So one of the answers we say to a lot of people when they ask why decentralization, we say, hey, it's not a silver bullet. It doesn't solve everything. It's not going to be this kind of huge panacea. It's a technology that has some great enabling factors, but it makes other things harder. And you need to find the right balance of those things for the right problem. Particularly for very heavy-duty asynchronous compute tasks, it's very nice. But for rapid response, latency-dependent tasks, probably not that nice right now.
Excellent. Yeah. So I'm going to keep an eye on this because at the very least it could be a good fallback. I want to switch to Andre because I had asked you earlier about latency numbers, and you said it compares to some of the services for scraping that I'm using. Are there things that that DePIN brings to scraping besides reliability and access?
Yeah, absolutely. I think when you're looking at a lot of the things that people are doing in crypto right now, sometimes there's this tendency to trend towards decentralization for the sake of decentralization, where you go and distribute a network that does not need to be distributed. What we're doing right now, like with web scraping, it's actually kind of an interesting problem because in Web 2, for decades now, this has been done as a distributed system. Large companies are scraping the entire internet using very similar technology, except instead of having users opt in and sell some of their bandwidth, they're sneaking SDKs into applications that they're downloading. You download a free VPN, you download a screensaver, you buy a new garage door opener that connects to the internet, there's a good chance that someone's adding you to an illegal, unethical botnet, using your internet bandwidth, leveraging your residential IP address that you're paying a lot of money for, scraping the web, and keeping all the monetization from that. We looked at this and said, okay, crypto works for this problem, not just for technical reasons, because crypto lends itself very well to peer-to-peer systems, and this is already a peer-to-peer system, and it cannot work in a centralized manner. And I can delve into that a bit deeper. But the bigger problem for us was an ethical one. And we kind of looked at the world and the way it was, and the way the internet was moving. Like there's all these other trends that are kind of parallel to this, where when you're accessing the internet today, It's no longer a place where you go to find things. It's a place where things come to, and they find you. And some people don't really like that very much. And you add these kinds of things to the mix, where people are just siphoning off and like acting like parasites and just stealing some of your resources. It's a world that we did not want to live in. And it was kind of a no-brainer. It's like, if we're not building this, someone else could build it. It doesn't really matter. This just needs to exist. And it didn't at the time. And what I mean by that is, you've got this way of doing things that crypto, it's one of those rare cases that crypto does not actually inhibit building this in a decentralized manner. So it was, why not? And yeah, to your point, some of the response times to our network are very comparable to these other ones. And a large part of that is because of the fact that they're built in a very similar manner, but with an extra layer of trust on top.
Yeah, so essentially what you have is a botnet that I opt into and get paid. I share in it. And I bring this up because I'm going to ask you guys regulatory questions later. And I think there's a twist there that's interesting. Jing, so I'd be interested to hear from you. I mean, you can talk about latency and performance, but Outex has been around in DePIN since obviously before it was DePIN. And what are you guys finding what are you learning about the demand side and about the supply side? Where is the supply of hardware, of decentralized hardware coming from? Because you're in the middle of all this. Where's the demand coming from?
Sure. So Outex, we have this kind of vision to connect all the devices and get all the device data and value and incentivization model on chain very long time ago. We started the project 2017. And until like 2 years ago, there is a new kind of term. We actually coined the term like machine-fi, and eventually like Masari and all the other kind of investors, they start to talk about the DePIN. So here we see like DePIN actually really kind of makes the understanding better. So it's about a decentralized physical network. So each network, they have a supply side and they have a demand side. If there's no demand side, it's almost like you don't really need to have created such a network. But right now, when we look at in the real world, what's the problem by many of the other kind of physical network? It's about the lack of the supply side, because most of the physical network, they are large scale, and they have to make it kind of deployed in any kind of area so that to make it usable for the the mass kind of public, right? And then only if it's a commercial benefits makes sense for the capitalists or the government, and it will do it. But for all the other kind of underdeveloped countries or regions, they basically lack of those resources. And answer your question, where those kind of demand side come from? Actually, it's easy. It's utility. Like those utility, it could be like wireless connectivity, energy, solar energy, right? Mobility, all type of the utility and demand side is there. But the problem is if we can create a really kind of massive and scalable kind of supply side. And I give you an example. One of our ecosystem projects they call kind of GODNet. So what they do location precision network, RTK network. So for their network, they only need to incentivize 20K, like 20,000 very large, the hotspot, covers the entire global. And then, you will have this network serve for all type of the use cases. They just give me a use cases. Right now, it's a growing kind of, automatic kind of grass mowing industry. So for this industry, they really need those type of very precise location network. But now there's no way for them to have the access to those kind of network. It doesn't exist. And then they started, they are basically the most usable network right now. And all the kind of the revenue and demand side from one single company. Right now, for the first year, they already kind of deployed 1 million, those type of grass mowing machine. Each machine worth $1,000, but they are willing to pay $10 per devices per year. And you can imagine only one use cases, they can get almost 10 million revenue for this network. And once the supply side is is there. Right now, they only cover US and later cover Europe. And once it's kind of global scale, you can imagine how many use cases or how many demand side can filter in. And this really kind of makes the entire flywheel can work.
That's nice. Yeah. So where so you're seeing most of the pickup in the U.S. right now on the demand side, or where are your biggest markets for this?
Yeah, so right now we will say the most established or the most adopted kind of DePIN projects they are in US. I think that's good because US always is the most kind of like capital intensive and also kind of most like acceptive to the innovation, right? So they take kind of US as a test bed. But just like biggest DePIN project like Helium, they also started and focused in US first, and then they validate the model and then expand to the other city and other region. Right now, they are already kind of start to expand to Mexico cities, and very soon to Europe. So I would say, like for DePIN project, just like all the other kind of shared economy, you need to test the model and the unit economy in a small scale first, and then expand to the other regions.
So following on that, for the other two projects, what are your timelines look like? Like what are the next milestones? When will I, as a Web2 founder, be able to connect to both of these networks and to start to use them?
Go ahead.
Yeah, so at the moment, all the scraping that's running through our network is being done by us. This is for two big reasons. I mean, the first one is the perfect way to stress test our network. Scraping huge corpuses of pre-training data is a really good way to congest a web scraping network and to test its limitations, just given the quantity of data that has to go through these things. And secondly, we haven't started compensating users yet, so we don't. It would go against our mission statement to start onboarding and monetizing a lot of this at this stage. So in the coming months, we'll be looking to open the doors, and at that stage, yeah, I guess. That would be.
Nice.
Yeah, so Outex, we already have a kind of a functional live platform to enable all type of the DePIN projects. So far, we already have over 30 projects that are live on our network, and we are empowering hundreds of other kind of DePIN network. And with our accelerator program, this year, by end of this year, you will see over 30 kind of new DePIN projects. They are all in different verticals. They will be launched on our network. And for our, because we are the modular platform, and our kind of demand side is actually all type of the DePIN builders and DePIN users, right? So Outex 2.0 is coming. With Outex 2.0, very soon, we will open our network even more. All type of modular infrastructure, they can join our platform. Not only Outex building all the modules and toolings, but we will open to all type of other kind of infrastructure builders. And we will also incorporate the AI kind of providers to make the DePIN network more useful, because you will know all the DePIN networks, they are connected to all type of device and sensor to capture the data. But how to make those data usable, and we will see like AI will play a very, very important role. All the machine learning models and all the kind of the on the edge, to do all the type of the kind of the algorithms to make like the normal users and also make the Web2 companies really easy to tap into the entire space.
Yeah, so for Jensen, we focus very deliberately on solving the technical problems underneath what we do. So decentralizing AI training is not a simple thing to do. It has very large promise, but underneath the technology, there's very hard problems to solve. One of the principal ones is verification. So the trust problem I mentioned earlier, AWS solves that with legal contracts and reputation and things like that. If you exist in a purely decentralized world where anyone with a compute device in the world can run Jensen and can be offering that compute, you have to have some way of verifying that they've actually done the work correctly. And that's an unsolved problem, essentially, in the world. We've been working on solving that problem for a few years now. We have the solution, but it's hard to kind of of bring into the world. So we're working very hard on engineering the correct solution, and we'll be testing that with people in the coming months. We tend to index towards quiet kind of tests rather than big launches and releases. So if people are close to us and are interested in testing it with us, if you have hardware or you have a demand-side use case for training a large-scale model over any device in the world, then just talk to us. We might test something with you. We probably won't announce it, but we'd like feedback. One of the other big problems we work on solving is how do you make efficient use of a network like this? So it's very nice to say, hey, we've verified the compute, we can use any compute device in the world, and functionally we've removed the scaling limits, but can I use 1 million GPUs or 1 million MacBooks to train a model? Right now, not really. There's not really any models that exist that can be trained over that infrastructure. So we do the research to build those models. Some of that is optimizing existing models. Some of it is building entirely new model architectures. It's another thing that if people have the compute and if they're working on that problem, we say basically come and talk to us. We won't do flashy announcements, but we will probably happily work with you. So just approach us. We might have something to test with you sooner than you might think.
So I've probably only got time for one more question. I'll go back to the regulatory thing because, you know, for you guys, what you're doing, the kind of attack surface is obvious, right? We're currently in a situation of trying to cap, you know, model training runs, you know, by the number of gigaflops, and you're essentially offering anyone the ability to spin up like something that's well above that cap, right? And then I know on the other side with Grass, you'll have the tokens. So we have, you know, we have compute, we have data, and we have the networking and the glue here. We have the full stack. And so I kind of want to go back through and ask, are you thinking about regulatory challenges? Like, is it something that you're already working on? Like how are you thinking about how what you're doing intersects with this?
Yeah, we think about it a lot from the compute perspective mostly, like you mentioned. For AI regulation, we don't believe the flop counts is a good way to regulate. What we do believe is that open development of models is a much better way to achieve exactly the same aims. Because what we want is auditability. We don't want very large organizations building these models behind the scenes that are absolutely enormous and then have capabilities that nobody else really knows about. I think you can solve that by telling those companies, hey, you have to go and report that to the government, but you can also solve it by saying, hey, why don't we just build models in the open? Other people can use those models. You get much more innovation across different companies. You get much more competition because you get smaller organizations able to use these models developed by larger organizations, but you also get that auditability, that everybody can see what is actually being done. We think that's a much better approach, and we're highly in favor of that. It works particularly well with our network because when you train something on a big decentralized network like ours, you can do privacy techniques, but a lot of those are in the realm of research. And in the future, we think those will be much more applicable for smaller scale fine-tuning runs, maybe specific models for specific people. These big foundational models will be trained in the open and should be trained in the open. In that way, they can be done collaboratively. They're not going to be a way of capturing value from other users and from companies. We've seen that already with OpenAI. OpenAI thought that training an incredibly large model would allow them to have a moat into the future that they could print money from, and then they realized that that model could be distilled very easily, and they had to start wrapping that in different business models, and some people might say we're going after regulatory capture approaches. We believe actually a better approach is just lots of companies coming together and saying, hey, if we train this foundation model together, we can build the APIs and the ecosystem things that OpenAI uses right now to gain revenue, but many companies can do that. We can have much more competition in the companies that do that, and the value propositions for those companies will actually be richer user interfaces, more specific, task-specific use cases, things like that. They're not in hoarding data and compute behind the scenes and then ensuring through regulatory capture that you're the only person that can do that. You pull the ladder up after you.
Yeah.
Andre?
Yeah, I mean, as you alluded to train a great model, not only do you need a lot of tokens, but you need the right types of tokens from the right types of places. One really interesting thing we've seen in the last few years is kind of evidence that markets with very instant gratification, like e-commerce and finance, tend to be this leading indicator of what's going to happen in other markets as technology expands. What I mean by that is programmatic access of data. This was already happening in e-commerce for decades. Companies were scraping each other's websites, putting up these walls, trying to make them very difficult to use, geo-blocking, blocking data centers, things like that. Very recently, up until recently, a lot of social media data, a lot of language data on the internet wasn't actually that valuable outside of the knowledge that it provided to people and outside of like just the advertising platforms that they came with. The moment these platforms realized that they were hosting a ton of very valuable data, they started engaging in the same types of behaviors as these aforementioned e-commerce companies. And by that I mean rate limiting users, logging gating certain information, blocking certain types of IP addresses. And what I find really interesting about this is the fact that logging gating is something that only Twitter really did. And the reason for that, and the reason that these e-commerce companies also aren't logging gated, is because they really heavily rely on things like SEO and types of programmatic access that benefits them directly as a platform in order to survive. So they need to make their information publicly available, but they make it very difficult to access. And as we see these types of gatekeeping and like centralization of power, it's something that we're very aware that our business model could disrupt. And as far as the regulatory side of things, it's not necessarily something we're concerned about. We are GDPR compliant. Like if we've scraped a data set, something that you've written happens to be in there, you want it removed, it'll be out of there. We're not scraping any personal information from people's devices. People that download these nodes, like it's like a trampoline on your roof. People can bounce off of it, but no one can actually come inside. Some of the bigger questions we actually are starting to ask ourselves are, outside of getting a network of millions of nodes to go and liberate this information from the grasp of these platforms, how do we bring some sort of value back to the people who actually contributed that information in the first place? So how do we bring it back to where it really belongs? And that's a very difficult problem to solve, actually. And from our perspective, the first step is actually liberating that data in the first place. And moving forward, that would be the next thing that we look at is how do we bring this value back to the people who contributed that in the first place? But yeah, to your point on regulatory stuff, we only scrape publicly available information, and we're fully compliant with all the relevant regulations.
That is about all we have time for. We've got about 9 seconds left. I'm sorry, Jing, we didn't.
I make it very short. The recent approval for ETF, definitely very bull kind of signal. It paves the way for all the DePIN builders, and especially for the builders which will really kind of working on the real world, adoptions. And also how to make kind of your asset fall into the decentralized category. It kind of paves the way. You can start as a more centralized token asset, but gradually when your node and the validators or whatever devices are getting more and more, you are getting more decentralized, and you become kind of fall into the decentralized utility asset. So I think no matter how, I think the clarity of the regulation really paves the way for all the DePIN builder, all the crypto builders, to work together and really for more decentralized future for human good.
Thank you. Thank you to the panelists.